Xompero, and Alessio is a research assistant at QMUL, University of London, and he is part of the Center for Intelligent Sensing. He is working very closely with Professor Andrea Cavallaro, and he's going to present the CORSMAL dataset called Containers Manipulation, and also present a CORSMAL demo that is the localization and shape estimation of containers. So over to you, Alessio.
Can you hear me?
Try again.
No.
Yeah, good.
Can you hear me? Yeah?
Yes.
Okay.
If you can keep the mic close because we cannot hear you very loud.
Okay, thank you. So, hi everyone. So thank you for the introduction, Ricardo. So I'm starting the presentation with the CORSMAL Containers Manipulation dataset that we collect here under the CORSMAL project. So I would like to start first with the CORSMAL containers, where we consider different objects as containers in this case, for example, cups, drinking glasses, bottles, and we collect images from two views in this case under different setups, for example, an office with natural light or a studio-like room with no windows. So for each camera that we use, we collect different type of data. In this case, we have RGB images, depth images, and stereo infrared images. And you can see here the variation in the background, for example, the tablecloth or just a uniform tabletop where the object was lying. And also we collect in total to 1,600, more than 1,600 images in this case when we were varying the objects and the illuminations. So let's have a zoom on the objects as we use in our collection. So we focus mainly on transparent objects, as you can see on the top, but we also include objects that are translucent and opaque. And in this case, are objects that are mostly used in household, and especially for specific tasks where they can contain liquids or even other type of fillings in this case. But here, most of the objects are without any filling, and we just collect images about those. The main challenges regarding these images is that the objects comes with different transparencies, shapes, and materials, as you can see on the images shown here. This dataset, first of all, primarily comes with a notation regarding the width and height, so the dimensions of each object, as the goal was somehow to analyze these type of properties when we vary all these shapes and materials of the object. Here is a link of this first dataset, but then let's move to something that is really interesting. So here we say the containers contain images from just two fixed views and with different type of object. But the problem becomes more interesting on what we have here, which is the CORSMAL Containers Manipulation. Here we have more than 1,000 audio-visual recordings where we use different views, so 3 fixed views and 1 first-person view, and different type of objects with different feelings at different levels. So this is making the problem even more challenging compared to what are just plain containers. And the further challenge is that there is people in the dataset that are manipulating the object, creating, for example, occlusion with their hands on the object, and make a perception system more difficult to estimate the properties of the objects in this case. So let's have a look at the actual setup of this dataset. As you can see here, we have the view 1 and view 2 that are fixed cameras that are on the side of a manipulator that in this case can be a robot arm, where the manipulator is equipped with another camera that here we refer to view 3, and we keep fixed for the collection of this dataset. The fourth view is worn by a subject, in this case by a person, that is going to manipulate a container with a specific filling. For example, here we have a cup with water. In addition to the videos, we collect also audio signals with a 8 microphone circular shape array. And we collect all the signals in a synchronized ways. So all the audio signals and also the views. And similar to the containers, we also collect RGB, depth, stereo, and infrared, which makes this dataset very interesting because of this multimodality content in the data. In addition to the fixed cameras, which we already have the poses, and we provide the poses, we provide also some inertial measurement data for the camera that is worn by the subject in this case. So having more precise look at the data set, that you can see here the 4 views as we were mentioning. So from the sides views, and on the bottom left, you can see the first person view, also from the camera of the subject that is wearing that camera. And in these videos, there are several challenges. So as you can see, there are occlusions on the top right of the object. There are transparent objects and opaque objects, as we saw also earlier on the CORSMAL containers, and the object can vary a lot in shape and size. And we vary again here, illumination and background, as you can see, for example, on the tablecloth, or for example, the t-shirt of the subject. Since we have also audio, there are some challenges also for the audio. In this case, we have some background noise during the recording that were produced inside the office where we collect the dataset, or even from outside noise that may affect a little bit the estimation that can be done through the audio signals. In terms of annotation, we focus here on estimating the properties of the object. In this case, for example, the filling type and level, the container volume, or the container and filling masses. On the bottom, you have a link to the actual containers manipulation dataset. But let's now move to some more details and zoom on the content of this dataset. So as objects, we use a subset of the CORSMAL containers, and some of these objects can be found also on what was mentioned in the talks earlier on the YCB dataset. And we consider specific objects like cups and glasses, which can vary in their rigidity and also the formability, but also we include the food boxes for their material property as well. For each of the container, we have different number of audiovisual recordings. So for glass and cups, we obtain 84 audiovisual recordings, but remember that we have 4 views, so the visual actually are in this case more than 400, and for food boxes we have in total 6 audiovisual recordings. Here we show training and testing as the dataset was split for the CORSMAL challenge. So we split all the data according to the type of containers, and we have 9 containers that are used in training and 3 in public testing. In total, the dataset comes with 15 containers, but we don't show here 3 containers because for the challenge, we decided to keep it private. So for each of the containers, during the collection, we choose different type of fillings. As you can see here, rice, pasta, and water. And we fill the object with different amount of fillings. So for example, we have empty, 50%, and 90%. For the food boxes, of course, water we cannot include it because otherwise we can destroy the material of the object. In addition to fillings, level types, and the container, we also record the data under different scenarios. So we have the first scenario where there is a person that is sitting and the object is completely visible in the first frame and then manipulated prior to deliver the object, for example, to the robot manipulator that we saw in the setup. In the scenario 2, the person is still sitting, but now the object is already handled by the person that is going to perform, for example, a pouring action of the content of the filling into the cup. And here the challenge becomes more related to the occlusion for the perception system. And the last scenario, which is the most challenging for each recording and for each container, is that the person now is not anymore sitting, is standing, possibly out of one of the field of views. And here we need to handle also all the motion of the person. We ask the perception system to handle this kind of challenges in this case. So based on the type of container, there are different manipulations. So for example, the person can shake an empty or already filled food box, or can pour a content into the drinking cup or glasses, as you can see on the middle and right videos. So here is some more samples of the CORSMAL container manipulation. All the video will come with audio actually, but it's not playing currently. And I leave here also a QR code that you can scan if you want to have a look at the dataset, if you want to download it, play it, give feedback and any comment that you would like, and to attend and participate eventually in the CORSMAL challenge that was mentioned earlier in the introduction. Thank you.
Thank you, Alessio, for the comprehensive presentation.